Hello, everybody. Welcome back. My name is Michael. Hope you're having a. Oop, showing a little skin here. My bad. How's it going? It's a little bit later than normal. Sorry, you guys. Just had a lot going on. I hope you're doing okay. Hey, Mon, how's it going? Welcome in, my friend. Thank you. I appreciate it. Yeah. I at least wanted to stop in and say hello for today. Probably not going to stream for very long, to be honest. But yeah, not really super feeling it. um, honestly don't even really know what to program, what to do here for today. I tried to start the stream and it gave me like an error at first, and so I thought that we maybe got banned, but apparently not. Looks like it was okay. I tried it again. It went through. Hello, Wing Hong. How's it going? Welcome back. Do I have a scheduled stream? Oh, I do. Sorry, let me delete this. I don't know why this is scheduled. Why I deleted. Give me 1 second, guys. Sorry. All right. Sweet. I think we're all good. Should we try to play some music again? Should we? Are we gonna get banned? Thank you, Wing Hong. I appreciate it. Yeah, sorry I'm a little late, you guys. I had a loss in my family um, today that was super. Well, it wasn't like as an older person, but it wasn't super. It was kind of a shock. Wasn't expecting it this soon, but yeah. So, but so I'm honestly a little bit. Don't really know what to do in terms of the stream today. Kind of just wanted to hop on and say hello. Maybe we can work on the project a little bit, and but I'm probably not gonna stay for too long. Hey Tanmay, how's it going? Welcome in. You picked a doozy of a stream to join back after your absence. This one's kind of a downer stream here. Sorry, man. Um, all right. Well, I don't know. We should at least just try to get some reading done, maybe. I don't know. I think that's probably the easiest thing to do. We don't have to really use our brain too much. I honestly feel don't feel like really using my brain hardly at all. I was really contemplating even not doing the stream tonight, but I wanted to stay consistent for you guys, and despite some of the hardships that went on today, um, it's all right. Figured that I can sit there and sulk and whatnot, but I can always just continue on and um, sulking is not really gonna make anything better. So just stay to the grind, and it'll probably make me feel better at the end of the day. uh, um, I have the Chrome extension for distraction as we talk. Let's check. Yeah, we can check that out some off stream on sometime. Hey AJ Brady, how's it going? I haven't seen your project. What is it about? Oh yeah, let's check it out real quick. So this is the small business manager project that we've been writing. I started to add in some some doc strings here, and we're gonna go through like one of these Saturdays and just take a day, a long stream, and just clean up these functions into their designated place. But well, what it does is basically It's a pretty cool program in terms of it's nothing like too crazy, but um, it's fun. It's just a small business manager where you can go into inventory through this menu, these repeating menus, um, and basically add in items. You can view and edit those individual items that you added, and then you can obviously just view them as a whole. You can transact those items for sale and by looking up their item number or whatever it may be. And then you can also load. We have a couple of bugs as you can see with our current format. You can also load um, expenses. You can create expenses here and then do the find edit as well on expenses, right? All these are different object oriented classes. And then you can ultimately, what that will do is you create a business. It has a business on the back end that's loading all this information or referencing all this information from these classes and generating some business statistics based on those transacted sales and whatnot. Oh shoot, I forgot to start my Twitch stream. Shoot. We are live actually on Twitch right now. Hello everybody on Twitch. This is my name is Michael. I'm 26 years old. I graduated from college back in 2021 with a degree in human biology and a minor in chemistry. I've been teaching myself how to code for about 6 months now. So if you're new here, please share with me, like, with the stream and chat, what your current experience is programming. Why you get into programming. I repeat myself almost 10 or 15 times a stream because people ask me why I got into it and what my current level and experience is. But I really care about and am interested on you guys. Um, so let me know what you guys your current levels and what you're passionate about in terms of programming, what you are interested in and welcome here. So we are actually got finally got the multi-stream to work the other day, so we are multi-streaming onto Twitch right now. But I'm a little bit apprehensive to bring the music back because we got almost got banned off YouTube. I guess. I don't know. I think it was a bug because I talked to support and they said they didn't see anything on my account, but they couldn't tell me why my stream was getting temporarily suspended for like 20 to 30 seconds at a time when I had the music playing. Um, my professor told me he wants to work. Oh, uh, sorry. Wing Hong, my professor used to tell me to just work when in tough times. Just work through the pain. Yeah, so sorry, this stream is a little bit of a downer stream. Sorry, I my grandma passed away today while I was at work. So my family's currently, going through it a little bit at the moment. But I appreciate all the kind words we've been given, and thank you guys so much. I wanted to hop on the stream and stay consistent here with you guys. I know I'm way late than my normal time at 7 p.m. PST. It's almost 10 o'clock. But I had a late day at work because I had a deadline today I had to release, and then compounded on top of that with that sad news. So, um, let's see here. Sorry, let me see. Lots of chats I'm missing here. Um, I'm learning myself, but what's your tips on actually retaining the information? Hey, Killam Feeds, how's it going? When I was first starting, and still am, I found it pretty difficult to remember all the information, and I oftentimes had the same question myself of how do you keep it all in your head and retain it all? I really try to push myself to remember. I guess it's yeah, obviously remember things, but obviously I don't like have the AI write code for me or things like that. Yes, I will ask the AI if I really can't remember things or along those lines, but I try my best to just do it all on my own. Um, but I also will say that just raw repetition really helped me. I really worked through a ton of just beginner problems, whether it be in the Python crash course book that we read live on the stream, or just by asking AI, hey, give me 10 beginner Python problems, and then trying to all work through them, right? And so I just really like pounded and pounded and pounded away on, that's what she said on on just Python practice over and over again. So that's what I recommend, honestly. Also, just making your own projects without any help and not watching tutorials. Yes, it is difficult. Yes, you'll sit at a blank screen for a couple of hours. Um, but by actually writing your own ideas and coming up with your own ideas and being able to translate those into code, similar to maybe like some of my beginner projects, task tracker, inventory management, small business manager, it's really helped to kind of springboard things in these short 6 months. Thanks for coming in and killing feeds. Appreciate you. Yeah, repetition, like AJ said. Is watching three blue, one brown playlist on neural networks copyright? We could do that. I'm not sure. I don't think so. I think you can watch reactions on YouTube, like other people's videos. Now, if they don't like it, then um, I'm not sure exactly, but yeah. You guys have any? No, the Prime again doesn't play the music on YouTube, but Twitch gets to jam. Oh, okay. So he has it filtered to one or the other. I wonder how he does that. He's a software engineer. He probably knows, not me. One day, maybe. I've been doing the repetition to be honest, but it feels like I'm still not grasping what I'm learning. But I've been studying on my phone while at work, and I'm at home coding on the phone at work. That's exactly it. Now I would just give yourself some more time. Honestly, killing feeds. Don't fall into that often those lies that creators make on YouTube and things like that, where they with fancy editing and the trick of editing and videos, they can make it seem like they know the information. Um, in the short 3 months since they started programming, right? And they got a job in 3 months. Like that's all kind of just BS, in my opinion. Just weed those out. Those are outliers if they are true. I really try to show my best to. I try my best to convey a live beginner point of view. I can't fake anything here live on stream. Um, and so whatever I'm learning, the level I've come, I've done this all live on stream. I've documented everything I've done pretty much. Yes, I've done a little bit of stuff off stream, but I stream every single day almost. So you see almost 98, 99% of what I do. So maybe just I would say follow a similar approach maybe if this is something that you're also interested in. Now this would mean no by no means saying that this is the right approach, but this is just one that I'm currently taking. Um, is it better to learn from a book than watching YouTube videos? In my opinion, I used to like videos for things, but now I've completely shifted back to like old head, where I really like books because it causes a little bit of mental math to happen. You have to be able to translate English text in the form of essays or whatnot, like reading books, right? Into code and make it make sense into code. And yeah, there's examples and things like that, but by going through that process and not just watching some guy do it on a screen for you, watching pixels change color, but you actually just reading black and white and then coming up with it in your mind visually thinking about what the for loop is doing. I'm thinking about and picturing these loops and going through these arrays. Like when I'm doing leak code problems with you guys, I'm literally like I write it down on my whiteboard all the time, but a lot of the times it's in my head. I'm very like in my head and about my thinking and stuff, and I try my best to bring it out for you guys. But I literally am picturing the array in my mind, going step by step and what's going on, and so um, there's this thing called like proprioception or something like that. For a fun fact, I was going to be a dentist. That's why I have like a degree in human biology and a minor in chemistry. I was going to go to dental school and try to become a dentist. A lot of my family members are dentists, and so I was like, I'll give it a go. But my senior year, I was just like, I just was not into that and whatever. But I was studying for the DAT exam, which requires you to like visually understand. Like it gives you problems about like how many sides are on, how many total sides are on a square on these squares, right? But it's like a stack of like 20 or something blocks just in a picture on a piece of paper, and you have to visually interpret all of the amount of faces that are touching or that are like open, right? So it is kind of like a programming problem. They're like I bet there are similar ones, but you have to do it yourself because if you think about a dentist, they look through mirrors backwards in order to do work. So you have to be able to have good like proprioception or whatever it's called. I'm not sure, but I bailed out of that. um, um, Thanks for asking the question, Jamps Code. I appreciate you. Let me know more about what you're learning. Same with you, AJ. Let me know more about you. I have found that YouTube tutorials usually aren't very helpful. The learning really does come just writing code from your own brain. Yeah, and a lot of the time, books help like nudge you to do that. The videos they kind of show you the code being written a lot of the time, but books they make you kind of write it yourself. I don't know, Mahan. People are liking the books. You might not like the books, Mahan. People are liking them. Hey Santiago, how's it coming? I appreciate you joining me here. When did you start programming? I started a little bit over 6 months ago. I started with Harvard CS50P and then I moved on to Python Crash Course to solidify the Python knowledge at the basic level. And then we went into Harvard CS50X from there, which we are currently taking right now. And we're also reading DSA in Python. So I want to go ahead and read like a couple of pages. Let's at least get to 415. It's not a lot, but we just need to at least keep the reading going, guys. Because think about it, we've been going this far. We can watch one episode. Mahan, you want to link me in the Discord an episode? Um, let's just read a couple of pages. We got to keep reading. I know reading might not be the most entertaining thing, but we've come a long way, guys, and we've learned a lot. This information was a good warm up and preface and introduction because we were able to take some of these data structures and algorithms and actually incorporate them and be very well suited for the Harvard CS50X course. When we were in week 3 on algorithms and then week 4 on data structures, we flew through those weeks because we were already prepared and already knew about time complexity functions and how to determine and evaluate sorting functions and things like that. Yeah, maybe we need a little bit more practice with certain sorts. I think we messed up on insertion sort leak code problem for like a whole 2 days, but it definitely shows that this learning does go a long way. It is dense, it is hard, but that's what she said. I feel like Michael Scott. I'm just making all these references over here. Okay, let's do a couple of reading, and then Mahan we'll watch an episode of the neural networks, and then we'll probably call it there. This is the shorter one. I'm sorry, guys. I normally hop on live 7 p.m. PST every single day. I just had to work really late. I had a project deadline today for one of my projects, so I had to release that to make the company some money. So did that. Still gonna keep my job, and then unfortunately I had a death in my family. So I just have been kind of emotionally dealing with that. So I came on a little bit later. But I still wanted to hop on for you guys and say hello. You guys really cheer me up every single day and make me feel better. You guys, honestly. So that's the huge reason why I did come on today. So all right, let's jump into a couple of pages here. All right, so we're on page 435 out of 770, guys. We've read 435 pages live on the stream. Like, if you guys think it's just like, oh, that seems like a lot, but all it really took was just me one day saying, I'm gonna start today and then not look back. And then every day, little by little, not quitting, 5 pages, 10 pages, 5 pages, 7 pages. I've gotten up to this point over halfway through this huge book. Okay, polynomial hash codes. So remember we talked about hash codes yesterday and how we need to have, pretty good hash codes to actually avoid collisions for our buckets when hashing. So these hash functions, what they do is they create a hash code, and then you have another function typically which will assign based on that hash code a bucket within the array, which is basically like an index. Um, right. So polynomial hash codes. Um, let's just read a few pages here and then we'll watch a video on networks that we're being recommended to watch. A basic idea, gotcha. Hey, what's going on, Richard? Welcome in. How old is that Python Crash Course book? They just recently updated the third edition fairly recently. Do they have an appendix for third edition date release? Um, fifth printing. 2023 was the last copyright for the third edition, so it's fairly recent for the third edition of Python. I read this back in October. This is what really, really solidified my beginner knowledge and helped me write my project so far. I'm actually considering going back through and just finishing the part two, which is actually the projects, and just getting some experience and practice with Pygame, and especially they have one with the Django, which I think we should definitely do. We should take a Saturday or a Sunday and just do a streamathon all day and just write the whole project in one day. What do you guys think about that? That'll be a fun one. I think we should set that up. I got a lot of ideas here. I also need to go back to our ideas. If you guys recall back to my stream idea where we're gonna every once in a while we're gonna randomly open up a Pokemon card pack. I gotta get some Pokemon cards, and then I'll collect the good cards or all of the cards really, and then I'll just give them away to the viewers every once in a while, like as on a giveaway. Like we'll save up a collection of 50 cards, and then we'll give away them to somebody, a lucky viewer, on the stream. So if you guys want to see that, that's something I'm interested in doing as well. I gotta do that though. Brother, I like what you said about focusing, looking back at the progress, focus, ready to work. Awesome. Thanks, Richard. Benny P, what's going on, man? Doing it yourself is big. I have used it to help understand topics and other subjects, writing functions to solve physics problems or chemistry formulas. Yeah, exactly. I remember that in college, I was constantly in the physics learning center, which with the graduate students trying to figure out some of these physics undergrad problems. Um, Richard, we're just on the same page here, man. Okay. The summation and exclusive or hash codes described above are not good choices for character strings or other variable length objects that can be viewed as tuples of the form x0, x1, all the way up to x minus 1, where the order of the x's is significant. So this is an array or a set. It's a tuple. Where the order is significant. For example, consider a 16-bit hash code for a character string S that sums the Unicode values of the characters in S. So let's break this down. A 16-bit hash code. So a hash code, remember, is a function that will produce a specific code based on some sort of underlying parameters. And if it's 16 bits, then that means that this code that's given back will be 16 either zeros or ones to make up some sort of binary value, right? So 16 bits or 2 bytes. Gotcha. I need to practice these bits and bytes. It's coming up more and more and more, and I need to get more fluent with understanding the counting concepts behind computer science here. Um, 16-bit hash code for the character string S that sums the Unicode values of the characters in the string S. Okay, so you would sum all of the Unicode values that represent the characters, and then that would be your hash code for the specific example. This hash code unfortunately produces lots of unwanted collisions. For common groups of strings in particular, temp01 and temp10 collide using the function, as do stop, tops, pots, and spot. A better hash code should somehow take into consideration the positions of the values at some indexes. An alternative hash code which does exactly this is to choose a non-zero constant. A does not equal 1. Some non-zero constant, a does not equal 1, and use as a hash code on the value. Oh, so basically be creating a polynomial for every position of x within this tuple. Okay. Mathematically speaking, this is simply a polynomial that a, the coefficient that takes the components x0, 1, all the way up through n minus 1 of an object x as its coefficient. This hash code is therefore called a polynomial hash code. by Horner's rule, C exercise C3 1 oh my god, C3.5, this polynomial can be computed as xn minus 1 plus a n minus 2 plus a n minus 3 all the way up to x1 plus, oh, so we're starting it from the back. X0. Okay. Intuitively, a polynomial hash code uses multiplication by different powers as a way to spread out the influence of each component across the resulting hash code, right? Because what if you had similar values? Well, then you would just need to, if you just multiplying by a every time, well, if you had a repeating value of 2 in your tuple, or 3 or whatever, well, then that would receive the same hash code if you were multiplying by the same magnitude every single time. So that's why we have to basically go up in magnitude for every basically position in the tuple, creating that polynomial effect to spread out um, basically the spread of that hash code. Okay. A bit 0 1 byte 0 0 0 0 0 0 0. Yeah, eight of those zeros are ones, right? Yeah. Okay, so polynomial hash code. A hash code where um, where a coefficient is applied to every value within some kind of what is it, iterable? Is it iterable or is it variable length? Object, strings, tuples, etc. Variable length objects with increasing order of magnitude to increase the spread and avoid collisions. Spread of the hash code, I guess. Each position in the object and avoid collisions. That sounds fairly decent. What's the italics? Is it 2? No, it's 1. Okay. So we'll say example. Right, where you have x sub 0. I'll just snip this. I'll just snip that right in the butt. Oh, not that, no. Well, I'm not going to take that one. Hold on. We want to take... give me an example of a polynomial hash, or polynomial hash code. Commonly used in string hashing. Okay, I like this guy here. Ooh, not that one. Not my title. Let's take that one here. What happens if I do that? Oh, it keeps all that crap. Never mind, I guess. We'll just go like this, and I'll just take this guy here. Copy. Just throw it in here. Okay. Horner's rule. Let's do Horner's rule. Let's look up what is Horner's rule. Latex, I'm trying to type math. Yeah, I just take screenshots of it. I'm too lazy to type out all the math. Okay, Horner's rule is an efficient method for evaluating polynomials, which reduces the number of multiplications required. Instead of computing each term separately, it rewrites the polynomial in a nested form. Okay, we'll take this definition. Ooh, why does it keep doing that? Okay. So his rule is like this. So a polynomial of degree n, right, typically looks like this, where you have a up time of n minus 1, all the way up to a sub 0, the initial value in this polynomial, or whatever it be, a tuple, where each value after the 0, 1 is multiplied by some coefficient. No. So x is the value we're looking for. A is our coefficient. So you do have a coefficient out front that you add by 1, and then you multiply it by x. It's been a while since I've done some of these. Okay. Reduces the number of multiplications from O of n squared to O of n, more numerically stable and commonly used in polynomial evaluation, the polynomial hashing and numerical methods. Example, evaluate this polynomial at x equals 4. Without Horner's rule, you do each individual, insertion of x. But with Horner's rule, you rewrite it as 2 times 4 plus 3. What? So this is our original polynomial here without Horner's rule, or right here. And then 2x third, 2x cubed, 3x squared, 5x plus 7. So you would take the coefficients 2 Why do you take the coefficient of the 3 and nest it within this plus 3? Oh, is that the exponent? 4 plus 5. What? Where is he getting some of these numbers? Polynomial 4. 2 times 4 plus 3 times 4, okay, plus 5 times 4 plus 7. Oh, so he's just... Interesting. N squared to n. Well, you just do it in one line, right? I think that's what it means. Is like you can just compute it in one pass of n just by going to the parentheses, and then outside the parentheses. Where here, I'm not sure. Yeah, I don't know. Let's see. Let's keep moving. Oh, my eyes are dry. Intuitively, a polynomial hash code uses multiplication by different powers as a way to spread out the influence of each component across the resulting hash code. Of course, on a typical computer, evaluating a polynomial will be done by using the finite bit representation of a hash code for a hash code. The value will periodically overflow the bits used for an integer, since we are more interested in a good spread of the object x with respect to the other keys. We simply ignore such overflows. Still, we should be mindful that such overflows are occurring and choose the constant a so that it has some non-zero low order bits, which will serve to preserve some of the information content. Okay, so basically you want to choose a constant that's small enough to where if you do overflow, basically you're allotted 16 bits for that integer, then you at least can contain some of the relative information within those lower level bits that are within the bounds of the overflow. I've got some sushi here, you guys. My work got it for me for staying late and making them some money. So I got some sushi here, so pardon me if I gotta crack it open here. Ooh. Ooh. All right. You guys like sushi? What's your favorite roll? If you guys like sushi, let me know your favorite roll in the chat here. I've got a California roll here, and it was called a spider roll. It's just got like tempura, crab, salmon, I think, on the top, avocado. It's kind of like just like a souped up California roll. Pretty basic over here. What basic white guy over here with his California rolls. I missed the little caret n in each of the terms for P4. That's where it reduces. Oh, let me go back. So in P4, yeah, you reduce all of the exponents. So there is no more exponent evaluations, right? Interesting. How do you actually write this though? Like, I'm not really, you start with a 7, you add it to what's next, you multiply it by 5, you add it to what's next, you multiply it by what's this, add it to what's next, multiply it by this. So you just leave off the exponents basically, but strategically do some sort of nesting instead. Okay. AJ and I are kind of getting it here. Spider roll, soft shell crab. Okay. Gotcha. Spider roll, soft shell crab. So I don't have any chopsticks, you guys. I have to use these two stainless steel straws. All right. Okay. We have done some experimental studies that suggest that 37, 33, 37, 39, and 41 are particularly good choices for a coefficient when working with character strings that are English words. In fact, a list of over 50,000 English words formed as the union of the words list. In fact, in a list of over 50,000 English words formed as the union of the words list provided in the two variants of Unix, we found that the coefficient A to be 33, 37, 39, and 41 produced less than 7 collisions in each case. Wow. 7 collisions over 50,000 words. That's a pretty good hash function, would you say? Hey, Carlos. Welcome back. Sorry, I got sushi flying everywhere here. All right. Um, um, Richard says, no, it isn't basic. It's soft shell crab, bro. You ever seen a soft shell crab? Their skin is crumbly and it tastes like a more gritty version of a crab. I said spider roll before you, by the way. Ah, I didn't even know what it was called. Yeah, so you know your sushi then, Richard. I I think I just don't know sushi that well. Like that's what I'm saying. Like my work gets it a lot because there are a lot of people that like it, and I do like it, but I always go for like the burger or fries. I'm kind of the burger or fries kind of person. I like or I like Hawaiian barbecue a lot too. I like what else? What kind of foods do you guys like? All right, we're doing a California roll this time here, guys. Which is that for you? All right. Mm-hmm. Mm-hmm. One sec. Okay. Cyclic shift hash codes. A variant of the polynomial hash code. Let me go ahead and actually let me put this in to the GPT before we move on from polynomial and see what if it likes my definition. Yep, that's a solid summary. Polynomial hash code uses coefficients to distribute values across a wide range, reducing collisions. Horner's rule optimizes polynomial evaluations by restructuring into a nested form, minimizing multiplications. Gotcha. Um, so this isn't an example of Horner's rule. This is just this guy here. Like so. And then Horner's rule is just a different thing here. Okay, so now we're on cyclic shift hash codes. Cyclic shift hash codes. A variant of the polynomial hash code replaces multiplication by a coefficient with a cyclic shift of a partial sum by a certain number of bits. Okay, here we go. Here we go. Well, average American. AJ Brady, you could probably compute it using some recursive function called summing at the end. Gotcha. Carlos says, we are back. Oh, yeah, I gotcha. Hey, Carlos, welcome in. Burger and fries, classic, yeah. Those are my go-tos. Burger, fries. Um, I like wings a lot too. I'm just American foods, I guess. You know. Profit Prodigy. What book are you using to learn? This is Data Structures and Algorithms in Python. If you guys want access to all the books and resources I'm using, my notes that you see on the left side, and the book, I provide everything completely for free in my Discord linked below. So go ahead and join there if you guys want to get access to any of my resources that I'm using to learn. Thanks so much for being here. You guys are awesome. Let me know more about you guys and what you guys are doing, why you're learning the program, what your experiences are. For example, a 5-bit cyclic shift of the 32-bit value 00111. Okay, so no, this is a 32-bit value, right? A 5-bit cyclic shift is achieved by taking the leftmost 5 bits, this guy here, and placing those on the rightmost side of the representation. Oh, so you just chunk, chunk, chunk. You just like choom, choom, choom. Okay, gotcha. Um, while this operation has little natural meaning in terms of arithmetic, it accomplishes the goal of varying the bits of the calculation. In Python, a cyclic shift of bits can be accomplished through careful use of the bitwise operators less than, and greater than, taking care to truncate results to 32-bit integers. Interesting. All right, we're almost gonna watch one of. Yeah, Richard, we're gonna watch one of their videos here in just a second. We're gonna get to 4:15 and then we will pause. Almost there. Mahan has been begging me to watch that. I'm kidding, Mahan, got you. All right, so a cyclic shift, right? A variant of the polynomial hash code, but replaces the multiplication of some coefficient. I suck at spelling. Right. A. We'll say A with a cyclic shift of a partial sum by a certain number of bits. Example. You have, I'm going to just copy this guy over. I like this example they gave. This helped make it. 32-bit value. Boom. For a 5-bit cyclic shift. Becomes this guy. Man, you guys, I am really putting in the work here on getting you guys some good solid notes. So if you guys enjoyed the notes, have ever used them, throw a thumbs up on the chat here. I am really grinding away here at getting you guys some thorough, detailed notes. All right. Oh, no. It copied the values. There we go. Yeah. Perfect. And we say the first 5 bits are the leftmost 5 bits are placed on the rightmost side thus a 5-bit cyclic shift. Right. Perfect. So then in Python, a cyclic shift of bits can be accomplished through the careful use of the, right? So we'll say in Python, right, this guy and this guy, operator, bitwise operators. Don't know what they do. Anybody know what these operators do and how they work? Bitwise operators can accomplish a cyclic shift, taking care to truncate results. Truncating results to 32-bit integers. Okay. Man, everybody suggests, have you looked into Obsidian or for Markdown note taking? Yeah, I haven't. I keep, keep making excuses, but honestly, it's just a lack of time. I get home from work, I hop on the stream, I end the stream, I usually edit a video, I go to bed, hop on, go to work, I repeat, repeat, repeat. So I've been doing that for the past 3 months. So it makes it, honestly, it is a little bit difficult to, so unless we actually are redoing the research on it live on the stream. But no, I need to stop making excuses. I need to one day just look up how to use Obsidian because I'm already using Markdown. Does it do something similar? I don't know. When you got time, give these images to Copilot and tell it to give you latex copy paste those there. Okay. Obsidian plus latex suite is so good for quickly writing latex. Shift bits left or right. Okay. Shift bits left, shift bits right as like pointing arrows. Okay. One more page and then we'll stop and watch a video here. An implementation of a cyclic shift hash code computation for a character string in Python appears as follows. Def hash code s mask equals a 1 shift 32 minus 1 limit to 32-bit integers. Variable h equals 0 for character in the string. H equals h 0. What? What is going on here? Anybody know what's going on here? Can you please break this code down line by line? Oh, there's a few issues with my code, huh? Well, the authors wrote it, not me. Let's go ahead and break it down what to do while also correcting the errors. My eyes are so dry. Hash code s, limit to 32-bit integer returning. Function definition. Defines a function named hash code that takes a single parameter, string s, single argument. Bit mask to restrict to 32-bit integers. Mask equals, parenthesis, 1 less than 32, parenthesis, minus 1. 1 less than 32 shifts 1 left by 32 bits, creating 0B1000000, which is in decimal. Shifts 1 left by 32 bits. Subtracting 1 results in 0, which is what in the world? Anybody familiar with these bitwise operations? These things are, what is going on? So we initialize a hash value. We loop through every character in the string. We shift the hash value left by 5 bits, equivalent to multiplying 2 to the power of 5 equals 32. And mask ensures the result stays within 32 bits. This shifts h right by 27 bits, taking the bits that were shifted out, combines them both together. Ooh, bruh. What is 10 in binary and decimal? One, yada yada, 1 bit is 10. I don't understand what these symbols actually do. What do they mean? 2 to the power of 1. So, yeah, 2. 0, 0, 0. So what is this 0B0001? What is that? Why do we have a B in there? Hey, Sundial, how's it going? Welcome. Appreciate you for coming in. You're awesome. Thanks for joining me here. We got a Twitch chat on here. If you guys don't know, we are streaming live onto Twitch right now. You can join and follow my Twitch linked in the bio of the YouTube stream. We are multi-streaming right now. Thanks so much for joining me here, Sundial. You're awesome. Appreciate you. The arrow means logical shift, I believe. See, you have 0, 0, 0, 0, 0, 1. Logical shift left. Okay. Oh, 0B is binary, like hex is represented by 0x. Okay, got you. You shift 1 to the left. Okay, yeah, see, this is where I need to like really take like a course or some problems on binary itself because I feel like it's a really, really honestly underrated skill to be able to kind of know these things. I feel like a lot of people do they really grind binary, hard? That's what she said in college for CS majors. Because I just, it's not like one of the things that people really talk about and things that you should learn as like an independent learner, like or really focus on. They're like, it's mainly just kind of brought up here and there in courses, but honestly, it keeps getting brought up in a lot of this more in-depth learning. Like audience, so but it makes sense because the more in depth you go about computers, like computers, it's all binary, right? So it's like, yeah, no dirt. I don't know. Sushi time, pizza time. Mm. Mm. The mask gets of all ones. Oh, the mask gets a 32-bit number that consists of all ones. Okay, because it's the maximum. The maximum. Okay, so they do this -1 to basically create like a uh not a buffer, but like I'm not sure what a mask really means, right? These variable names are kind of elusive, like mask. Like it's just, but what exactly? So you're saying that 0B, so this is binary, and then 1, 0, all the way through for 32 numbers, right? For 32 bits. So we have 32 bits where the first value here, or the leftmost value, is 1, giving us this value in decimal. What does it mean by in decimal? Because when I hear decimal, I think of like a decimal point, but I don't see any decimal point in here. Does decimal just mean like in decimal as in like in integer form, like as in binary, in decimal, the Dewey Decimal System? That's what I think comes on top of my head. Um, the mask gets the 32-bit number that consists of all ones. This is then ANDed. to turn and ed to turn all bits above bit 32 to 0, keeping all other bits unchanged. If each bit is a card in a deck, it's like taking however many off the top or bottom and placing them on the other end. Yeah, exactly. That makes sense, Benny. It's not an introductory topic, but it's very important to understand. I got you. At least for me, binary has been brought up in at least one class per semester. Yeah, it just keeps getting brought up for me here, and I keep kind of passing over, like, oh, we'll learn that later, we'll learn that later. But honestly, it seems like it might be beneficial for us just to bite the bullet here and try to learn this kind of more in-depth binary analysis here. Basically, you get the value of 2 to the power of 32 and subtract 1 to set that value that is all ones. The mask is used to enable/disable bits. Oh, got you. Decimal means base 10, our numbers. Okay, got you. Binary is base 2. Yeah, exactly. The mask is just short form to encode. The mask is just a short form to encode a set of large n elements. So if the ith element is 1, that means the element that is it means that element is included. If 0, it's not. And then if you loop over all the mask, you get all subsets. Oh. Oh, so you're saying like if you have some sort of set of like tuples or whatever, right? Because we're talking about creating hash maps, right? So you have some set of tuples, you can create a mask, right? That kind of think of like a cloud that hovers over the array in equal length, but it only has 32 bits. What if your tuple has larger values than 32? Like 32 characters in a string, Alex. I don't know. I think I need to like really like get like a book or like watch some more videos on like actual binary, more like grind it away here, because this stuff does not really make sense to me. I know you guys are doing a great job trying to help me out and explain it, but let's go to a whiteboard. Let's try to walk through it here. So what is this first line doing essentially? Right? What is this mask doing? It's creating a 0B, right? So a binary number. So I'll do 0B. So a binary number where 1 is the first number, where we shift 1 all the way, and then zeros all the way times 30, or times 30, it'd be 30, right, values. Because we have 2 already. As an eye, wow, 1.44, that K, we hit that. Let's go look at my phone here. Oh, hey, Miss Kitty. Oh, are you sleeping? Miss Kitty was sleeping. My kitty was sleeping here. Come here. Come on, you want to come on stream? Come on. Come on stream. Come on. Oh, I got her. Haha, you guys, special feature. Whoa, Miss Kitty. Oh, she loves that. Oh, yeah. Oh, yeah. She's a cutie. Um, Brian Gomez Hernandez, then you just adjust the size of the mask, but it's mainly for logical operations, I believe. Okay. Alex has solved some leak codes. Numbers in Python can be larger than 32 bits if I'm not mistaken. If you have a number that's 64 bits and you mask it as shown, and you mask it with the mask shown, you set all the bits above the smallest 30 above. 64 bits, and you and it with mask shown. Oh, you and it with mask. Right here. You set all bits above the smallest 32 to 0. Hmm. Interesting. All right. Let's keep moving here. We'll have to do some more learning on this one. But so, right, that's what that represents is 0b 1 0 0 0 0 0, which is a huge number in base 10. Subtracting 1, why does, now tell me this, I just don't know. Maybe it's not as obvious for me. Why does subtracting 1 essentially flip every single other zero, all 31 zeros within this initial call of 1, this, 32? Why does the -1 flip every zero to a 1 from here forward and create basically the largest decimal number we have that we can make with 32-bit unsigned integer? Right, because if all 32 bits are flipped onto 1, well, it means that that's the largest or max 32-bit integer, right? Because you have base 2, 4, 8, 16, 32, and you just multiply value. No, you don't multiply. How do you count them again? You go, oh, shoot. The operator and is logical and. 1 and 1 equals 1. 1 and 0 equals 0. Okay, so logical and. 1 and 1 is equal to 1. 1 logical and 0 equals 0. So 0 is the preferred value, is the overriding value when given the logical and. I'm sorry, I'm just not really sure what it does. I get it. You might be frustrated. I'm sorry, but I'm just not really sure what it does per se. It 0 like a truncating factor. Like if you have a 0, you return 0 when you do the logical and. If you have 1 0 0 0 and subtract 1, you get 9 9 9, which flipped all zeros to 9. Oh. Oh. So you're literally just subtracting 1 from this binary value. Zero b 1 0 0 minus 0b1 equals to 0b0 1 1. Bits got flipped. Bits got flipped. Okay, so okay, I see what you're saying. So if you subtract that order of magnitude bit out, you have to basically compensate for the cascading just as you would do in subtraction. How do you show numbers in the form of 2 to the power of n minus 1? How do you show numbers in the form of 2 to the power of n minus 1? What do you mean, Mahan? True and false equals false. True and true equals true. Oh, okay, so true and false equals false. True and true equals true. False and true equals false. False and false equals false. How I learned it in discrete math. Okay, got you. So something that is false cannot be true, but something that has two truths can be. You have to have two truths to make it true. But something that is false is the overriding, is a truncating factor of false. So 0 technically is the false in that analogy. So it is the truncating, right? If you have a false in there, that statement is false. Okay. Both values in place must be 1, and any zeros result in 0. Interesting. Okay. Feeling a little bit better about this. Appreciate all your guys' help with that. Let's finish this page, and then we'll go on to that video here. As with the traditional polynomial hash code, fine-tuning it is required when using a cyclic shift hash code, as we must wisely choose the amount to shift by for each new character. Our choice of a 5-bit shift is justified by experiments run on a list of over 230,000 English words comparing the number of collisions for various shift amounts. So if you shift 0, you have a lot of collisions. So there is a sweet spot. If you start shifting too much, then you start to go the opposite direction. You have like an inverse curve here. Inverse bell curve, I mean. Or a regular bell curve, depending on how you look at it. No, regular bell curve. No, inverse bell curve, because it starts at the high of values and goes back up to high. So you have an inverse bell curve, but you have a couple outliers, like 11 shifts. That 5 shift mark is pretty nice. 9 isn't bad either. Tanner asked, what extension are you using to get the ChatGPT flyout? Yeah, so if you just download the ChatGPT app, I don't know if it's online or if it's on the App Store, I'm not sure, but if you just download the ChatGPT app, right? And then if you just have it, if you just open it and then you can close it out, you can actually options. There's a thing in the settings, I think, to have option space be your hotkey for just doing a quick search. So like if I press option space, kind of like command space is the spotlight search. More of a W curve. Yeah, that would make sense because you have these spikes here. So you'd come in, you come down, then you have some spikes here that have a little bit of some teeth to them basically, and then you would come back up. You'd come back down again and then back up. Yeah, exactly. W. Mm, 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 mm. 2 to the power of n. Yeah, 2, 4, 8 in binary. So when you say 2 to the power n, that's just the base 2 for binary numbers, and then n is just what does n why do you say n in with when you do like that binary representation? Like what does the n actually compute to in terms of like the number of like can you just like is there like a little hack to say like the n is equal to the number of bits total? Like in terms of like counting bits is proportional to n? Logic table. Yeah. Yeah, that one looks similar to the one that was it AJ showed us? Yeah, AJ. 2 to the power n is the decimal. Is the decimal. I thought 2 is the base of binary, right? Why are you saying decimal there? Okay, comparison of collision behavior for the cyclic shift hash code of apply to list of 230,000 English words. Okay. All right. That's a good place to stop here on page 415. We're going to go ahead and watch a video per recommendation. Let's go pull that up. Thank you guys so much for being here. I appreciate you guys so much. Sorry I'm a little bit later than normal. I had a work deadline I had to work deadline I had to finish for this evening. I didn't get off work until around 7:30, and then I had a unfortunate death in the family, so I kind of was emotionally dealing with that, while I was at work at the same time at work, and so. Anyways, sorry for the later stream tonight. I will be back on the normal hours tomorrow, 7 p.m. PST. Yeah, AJ Brady, please, please, I would really appreciate it if you could. You can join the Discord, and um, if you want, you can post there's a community resources tab, and you can make a thread post for your own, and just continually add to that thread post all the resources for AJ Brady, and then everybody can access them, and I'll check them out there. That'd be great, man. I really, really appreciate that. And it's basically how many bits. Okay, yeah. Thank you, Miles. I appreciate you so much. You're awesome, man. Thank you, Brian. Appreciate you. You guys are great. Yeah, it was my only living grandma. She was in her 80s, but it was super unexpected. She was moving and talking and eating a lot, and she was in a lot better shape than my grandpa. But uh, yeah. Anyways, I thought I would at least come on and code with you guys for a little bit and do some learning and keep the streak alive. I didn't want to let the streak die. Some people say that working while you're in the dumps is good for you. Um, sorry. Okay. Let me see here. Let me open up Dish. Okay. Now let me make sure. I'm gonna go ahead and just really quickly, just in case they get upset, I'm gonna quickly turn off my monetize so that they can't get butthurt at me for watching this. I don't think this guy would get mad considering he's quite large, and my little stream ain't gonna do nothing for his copyright. But um, you never know. I'm sure, and it's probably very educational in terms of like he probably encourages you to learn. So, but I don't want to take any chances. How do I do it? How do I do it? Content, short videos. Um, okay, there we go. Okay, I just turned it off for the time being. Not gonna get hit with no strikes. All right. Let me know if you guys ever seen this, watched some of this guy's videos. We've recommended him through the channel to get an introduction here. We'll watch this video and then we'll probably call it there for the evening and we'll come back tomorrow. Um, please, if you guys have any suggestions for what you guys think I should learn, I'm kind of honestly running into like a brick wall like in terms of what I would like to do on when I was first starting there was just so much to take in like yeah I had to learn functions, I had to learn loops, I had to learn all this, all that, but now I'm starting to reach to a point where my learning is starting to plateau, not in terms of just of the actual what we're learning. We're still taking in a lot of knowledge, but um, it's just like that we're not taking in as much new topics because we're learning harder and harder things, so it's taking longer and longer to get over those humps. So if you guys have any suggestions for things that you think would be I should learn or take a dabble into, please let me know, whether it be a message or in the Discord or something. I'm really looking for things to do for this stream and channel. Whether because I don't know, we're gonna finish the CS50 course here soon, and we're going to need to fill that slot with something. But without further ado, let's go ahead and jump into this. This is But What is a Neural Network? Deep Learning Chapter 1 by 3 Blue 1 Brown. Check him out if you guys want to. I appreciate you guys being here and joining me. All right. Anyone who has a passion for learning various technical concepts will love this channel. Definitely worth a subscribe. I'm sure you'll get it. All right, let's go ahead and throw this up. We'll take your guys' word for it. Let me know how the audio is.
This is a 3. It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea, while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this, and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network quote-unquote learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits.
That looks so complex.
This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo here, because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants. But in these 2 introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number. Specifically, a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels.
Okay, that's kind of like the CS50X
This number
problem.
Inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784...
Okay, so we did something kind of similar, not neural networks, no, but on the CS50X problem, we iterated over a matrix and did like blur and applied filters using C to detect various pixels intensities, kind of like this.
Neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons, and admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment, and 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now, the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing?
Okay.
Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now, in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these subcomponents. That anytime you feed in an image with, say, a loop up top, like a 9 or an 8, there's some specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents corresponds to which digits.
Oh.
Of course, that just kicks the problem down the road, because how would you recognize these
Yeah, that's
subcomponents,
what I was
or
gonna
even
ask,
learn
like,
what the
well,
right subcomponents
How
should
do you
be?
even recognize
And I
the
still
loop
haven't even
then?
talked about how one layer influences the next, but run with me on this one for a moment. Recognizing a loop can also break down into subproblems. One reasonable way to do this would be to first recognize the various little
Curves.
edges that make it up. Similarly, a long line, like the kind you might see in the digits 1 or 4 or 7, well, that's really just a long edge, or maybe you think of it as a certain pattern of several smaller edges. So maybe our hope is that each neuron in the second layer of the network corresponds with the various relevant little edges. Maybe when an image like this one comes in, it lights up all of the neurons associated with around 8 to 10 specific little edges, which in turn lights up the neurons associated with the upper loop and a long vertical line, and those light up the neuron associated with a 9. Whether or not this is what our final network actually does is another question, one that I'll come back to once we see how to train the network. But this is a hope that we might have, a sort of goal with the layered structure like this. Moreover, you can imagine how being able to detect edges.
When he says train the network, I just imagine he's got a leash around his laptop and he's like, move! Come on! Get moving!
Patterns like this would be really useful for other image recognition tasks. And even beyond image recognition, there are all sorts of intelligent things you might want to do that break down into layers of abstraction. Parsing speech, for example, involves taking raw audio and picking out distinct sounds, which combine to make certain syllables, which combine to form words, which combine to make up phrases and more abstract thoughts, etc. But getting back to how any of this actually works, picture yourself right now designing how exactly the activations in one layer might determine the activations in the next. The goal is to have some mechanism that could conceivably combine pixels into edges, or edges into patterns, or patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about.
Okay.
And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker. When you compute a weighted sum like this, you might come out with any number. But for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range between 0 and 1. And a common function that does this is called the sigmoid function, also known as a logistic curve. Basically, very negative inputs end up close to 0, very positive inputs end up close to 1, and it just steadily increases around the input 0. So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like -10, to this weighted sum before plugging it through the sigmoid squishification function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active. And that is just one neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer. And each one of those 784 connections has its own weight associated with it. Also, each one has some bias, some other number that you add on to the weighted sum before squishing it with the sigmoid. And that's a lot to think about. With this hidden layer of 16 neurons, that's a total of 784 times 16 weights, along with 16 biases. And all of that is just the connections from the first layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them. All said and done, this network has almost exactly 13,000 total weights and biases. 13,000 knobs and dials that can be tweaked and turned to make this network behave in different ways. So when we talk about learning, what that's referring to is getting the computer to find a valid setting for all of these many, many numbers so that it'll actually solve the problem at hand. One thought experiment that is at once fun and kind of horrifying is to imagine sitting down and setting all of these weights and biases by hand, purposefully tweaking the numbers so that the second layer picks up on edges, the third layer picks up on patterns, etc. I personally find this satisfying rather than just treating the network as a total black box, because when the network doesn't perform the way you anticipate, if you've built up a little bit of a relationship with what those weights and biases actually mean, you have a starting place for experimenting with how to change the structure to improve. Or when the network does work, but not for the reasons you might expect, digging into what the weights and biases are doing is a good way to challenge your assumptions and really expose the full space of possible solutions.
Oh, come on.
With Google Workspace.
Just killed the mood.
The actual function here is a little cumbersome to write down, don't you think? So let me show you a more notationally compact way that these connections are represented. This is how you'd see it if you choose to read up more about neural networks. Organize all of the activations from one layer into a column as a vector. Then organize all of the weights as a matrix, where each row of that matrix corresponds to the connections between one layer and a particular neuron in the next layer. What that means is that taking the weighted sum of the activations in the first layer, according to these weights, corresponds to one of the terms in the matrix vector product of everything we have on the left here. By the way, so much of machine learning just comes down to having a good grasp of linear algebra, so for any of you who want a nice visual understanding for matrices and what matrix vector multiplication means, take a look at the series I did on linear algebra, especially chapter 3. Back to our expression, instead of talking about adding the bias to each one of these values independently, we represent it by organizing all those biases into a vector and adding the entire vector to the previous matrix vector product. Then as a final step, I'll wrap a sigmoid around the outside here. And what that's supposed to represent is that you're going to apply the sigmoid function to each specific component of the resulting vector inside. So, once you write down this weight matrix and these vectors as their own symbols, you can communicate the full transition of activations from one layer to the next in an extremely tight and neat little expression. And this makes the relevant code both a lot simpler and a lot faster, since many libraries optimize the heck out of matrix multiplication. Remember how earlier I said these neurons are simply things that hold numbers? Well, of course, the specific numbers that they hold depends on the image you feed in. So it's actually more accurate to think of each neuron as a function, one that takes in the outputs of all the neurons in the previous layer and spits out a number between 0 and 1. Really, the entire network is just a function, one that takes in 784 numbers as an input and spits out 10 numbers as an output. It's an absurdly complicated function, one that involves 13,000 parameters in the forms of these weights and biases that pick up on certain patterns, and which involves iterating many matrix vector products and the sigmoid squishification function. But it's just a function nonetheless. And in a way, it's kind of reassuring that it looks complicated. I mean, if it were any simpler, what hope would we have that it could take on the challenge of recognizing digits? And how does it take on that challenge? How does this network learn the appropriate weights and biases just by looking at data? Well, that's what I'll show in the next video. And I'll also dig a little more into what this particular network we're seeing is really doing. Now is the point I suppose I should say subscribe to stay notified about when that video or any new videos come out. But realistically, most of you don't actually receive notifications from YouTube, do you? Maybe more honestly, I should say subscribe so that the neural networks that underlie YouTube's recommendation algorithm are primed to believe that you want to see content from this channel get recommended to you. Anyway, stay posted for more. Thank you very much to everyone supporting these videos on Patreon.
Bro got 7 mil
I've been a little
subs
slow
saying
to
the
progress in the
algorithm's fighting
probability
him.
series this summer,
Bruh,
but I'm jumping
come on.
back into it after this project, so patrons,
18
you can
mil
look out
views
for
and the
updates there.
algorithm's fighting him.
To close things off here, I have with me Leisha Lee, who did her PhD work on the theoretical side of deep learning, and who currently works at a venture capital firm called Amplify Partners, who kindly provided some of the funding for this video.
What do you think her salary is? Throw a spitball number. What do you think her salary is?
So, Leisha, one thing I think we should quickly bring up is this sigmoid function.
500 at least? At least? 800? 1.2 at the max?
I understand it, early networks use this to squish the relevant weighted sum into that interval between 0 and 1, you know, kind of motivated by this biological analogy of neurons either being inactive or active.
Exactly.
But relatively few modern networks actually use sigmoid anymore.
Yeah.
That's kind of old school, right?
Yeah, or rather, ReLU seems to be much easier to train.
And ReLU stands for rectified linear unit.
Yes, it's this kind of function where you're just taking a max of 0 and a, where a is given by what you were explaining in the video, and what this was sort of motivated from, I think.
Dude, I don't know why do they not tell you just, honestly, is it like, chill, Richard, come on, don't disrespect her like that. She's the machine artist. Honestly, why don't they just tell you if you want to make a bunch of money, just become really good at math? Like, that's kind of what I've been noticing here is that all these people they're either like CEOs, right? Or they're really good at math.
Is a partially by a biological analogy with how neurons would either be activated or not. And so if it passes a certain threshold, it would be the identity function, but if it did not, then it would just not be activated, so it'd be 0. So it's kind of a simplification. Using sigmoids didn't help training, or it was very difficult to train at some point, and people just tried ReLU, and it happened to work very well for these incredibly deep neural networks.
All right, thank you, Alicia.
All right, that was 3 blue, 1 brown. Chapter 1, Deep Learning on what is a neural network. Honestly, that a lot of that flew over my head. We don't know much about vectors or linear algebra. We knew a very minimal amount about matrices, but it was just kind of an idea that essentially for this specific one, you're just evaluating, like you said, the edges, and then these nodes at each stage are basically evaluating these edge clauses and putting them together kind of like a puzzle and then spitting out an answer. And then you can, it's kind of like if you ever like mix and master, you've seen some of those studios, if you guys know music at all. It's kind of like those studios that have just a bunch of knobs where you can, on the compressors and on the whatnot, that you can tweak to get a slightly different sound or a slightly different output, right? That's kind of what I'm envisioning. It's like that huge soundboard with all these knobs and stuff on it. There's a deep learning research that just turned to of because made more money. What kind of English was that, Scary Sticks? Mahan, it's already 11:30 for me. Unfortunately, tomorrow I've got my final day of my project, my product. My product has 3 levels associated with it, 1, 2, and 3. Go figure. Each at varying concentration levels. I released my 1, my low, and my 3 already, and now I need to release my level 2 tomorrow, which is a blend of them. So unfortunately, tomorrow will be a little bit of a longer day. Hopefully, I can get out of there sooner and be able to start the stream at the normal time. I'm pretty sure I'll be able to start at 7 tomorrow, no problem. The level 2 is a little bit easier. Today was my level 3, so it was my higher concentration level that I had to filter today. And my filtration alone, right, I was 335 liters. My filtration started at 2 and finished at 6:30. So 4.5 hours to filter 335 liters, which is a long time. That's not a crazy amount of solutions. It was just, I had to swap filters. I probably went through like 10 to 15 filters. And when you change a filter, you have to depressurize the whole apparatus, the filter train, because you have canisters that have the filters inside of them that are 30 inches tall, and it was a train of 5, and you have to depressurize the entire train, flush the train, and then unscrew the filter, but you have to do it sterilely as well. So it was a doozy, man. I got blasted by serum over and over again. Oh. Oh, gotcha. There is a deep learning research that just turned to some more money. OnlyFans. Yeah, you guys bet her salary is 500K. It's got to be higher than that. Where does she work? Venture capital? Deep learning at a venture capital? It's got to be more than 500. I've seen some salaries posted on Reddit and stuff I'm not sure how true they are, but I've seen some of these like quant traders, venture capital mathematicians be raking in like 650 to 850. Like it's just nuts. I don't know. I don't know how true those are, but I've seen a couple of them. They're just knowledgeable. I don't know if you have to be insanely good at math, more so applied knowledge. Yeah. She seems like she knows she's good at the math, but then she can actually knows what she's talking about with applying it to stuff, which is really admirable. Really good deduction. There's a video of how they made machine learning models in the 40 with knobs and stuff called the Perceptron. This was released before AI got huge. Yeah, this just goes to show you guys that people, I think, this is what I think, like when people talk about AI bubbles in terms of the market, this is why I think people, yeah, you might have some sort of downturn in the market. I'm not no market genie, but in my honest opinion, now like I said, I'm not no genie. I've just been watching it for the past, few 5 or so years, pretty dedicated. Um, is like I like look at it. Like this was before AI came out, like you guys said, and they were working on this, developing it, trying to to get these kinds of models to work way long ago. They've been doing this for all of this time, and people that don't know about that, they think that this just started happening right now, and they don't realize that this has been cooking for decades, right? So it just goes to show you that there's strength behind this, and I don't think it's going to go anywhere. Darko, hey, what's going on? Where do you learn Python? Yeah, so you can. I highly suggest you join my Discord. Link down below. Woo. Oh my god. Where you can access all of my study resources, from Python Crash Course to asking personal questions, Python Crash Course, DSA and Python that we're reading right now, Fluent Python. We have some courses in here. You can take some my personal weekly updates for the CS50X that we're taking. I need to do week 7. I'll try to get that out tonight. I know I've been saying I'm gonna update the Python one. I just have not yet. I'm sorry, guys. Man, I got like allergies or something. My nose is all stuffed. But then we're gonna get into math, you guys. We're gonna become like Lisa here. Is it Lisa? Hopefully, I didn't just say her name wrong. We're gonna get like her and become math pro. We're gonna get math good. So join along if you want to learn math with me. We're gonna do our best here to try and really grind all the math. Hello, Lil two Lek. How's it going? I appreciate you for joining me. You're awesome, man. How's it going? Welcome. Um, where do you learn Python? Thanks. I'll find that. Since the back propagation papers came out. What? The main issue I can see is actually making the products profitable, but it's burning so much cash right now. Yeah, right. I mean, it's eventually. I mean, it's just a matter of time, right? You just gotta think about like think about SSDs. Those things were like $200 for like a 120 gigabyte SSD back in like 2013, or they were more than that. They were like $400 for that much, and now they're like 20 bucks. I remember like when I built my first computer like in high school, like my freshman year of high school, I had like grind for my most expensive things were, funny enough, were the not only the graphics card and processor, but the SSD was the most expensive thing on the build. Um, last 3 videos got released recently. It's about GPTs. This is what I usually think of AI. Lil Tulek, do you have any videos on how to do variables and expression loops? Yeah, Lil Tulek, I highly suggest you take a look at some of my Python Crash Course videos. We read the book Python Crash Course live on the channel. I also provide a copy of my notes in PDF in the Discord down below. We read the whole book live on the channel, at least the part 1, the learning portion. And I'm going back through and posting, individual solutions to the practice problems inside. I also have a personal GitHub repo of all of the answers completed, my own, that I go back and reference as well. So highly suggest you take a peek at that if you're looking to get into Python, and join along to the channel so we can talk and network in the future, man. Welcome. Appreciate you for joining. What's your goals here for programming? Have you read Automate the Boring Stuff with Python? That book really helped me in my career in Python. It got me into freelancing. I haven't read that one specifically, but we did read Python Crash Course. Would you guys think it would be beneficial for those that have read Automate the Boring Stuff? Do you guys think it would be beneficial at my current level to read that one, or do you think it might be kind of backpedaling? Now, obviously, all information is good information, whether it be review or not. So, is that something you guys are interested in? I was considering also reading that book as well, and we could get through it pretty quickly, considering that these books aren't too dense. Do you guys like that sound? Should we read that book on the channel? I was really wanting to think about getting into it, but I want to know what you guys think. Currently, we're reading the data structures and algorithms in Python. We're on page 415 out of 770, so really making some progress here. But anyways, you guys, I'll stay here and chat. I'm not going to do any more programming tonight. It's already 11:40 p.m. for me. I have work tomorrow. For those that don't know, my name is Michael. I'm 26 years old. I graduated from college back in 2021 with a degree in human bio and a minor in chemistry. I work as a formulation chemist for a biotech company. I was going to be a dentist, but I decided to go into chemistry instead because I didn't want to go to dental school and do all that stuff. I kind of got the heebie-jeebies about working in people's mouths and stuff. It just really, I kind of, my senior year, I kind of had this whole, like, I don't want to do that anymore. So I've been teaching myself programming for about 6 months, and it's been quite the journey so far. We've got a couple of projects that we've been writing live on the channel. Just to show you guys really quickly, this is the small business manager that we've been writing live, where we, take in inventory items, expenses, and transact those inventory items, and ultimately develop and hopefully I'll add in another feature here to provide, actual business reports. And I was thinking that we could incorporate the SQL that we've recently learned, the SQL, to actually do SQL pull requests, SQL queries to do that report generation. Like, why am I wasting my time using print statements to show all of these information when I could just load SQL? Maybe I don't know. We haven't learned SQL in JSON, but in CSV we did. I'm sure they have some sort of JSON equivalent or something or mode within SQL that we can use to actually just basically report out a formal SQL query, a printout of the basic business information, and then we can, specifically tailor those queries to just like subqueries of within or just this information or just this information or filters or things like that. So let me know what you guys think about that if you have any ideas as well. SQLite or LibSQL will be a good application level database. So my question is, AJ, is we currently are running everything within JSON and using hard saving on files. Now, how could I easily intertwine that with JSON? I don't want to have to like backtrack and basically like deconstruct my program like all the way over again because we already had to do that once. Like I originally wrote this using CSV files and then we learned the JSON files using, and then so we're like, okay, let's try it, let's convert it. So we went back and reconstructed and refactored it all into JSON, but I don't want to have to like do that again. That's a big ask. um Thanks so much, Lil Tulek. I appreciate you for coming in. I stream every single day. I look forward to hearing back from you again. Make sure to stop in and learn alongside me. You're awesome, man. Welcome. um, are you planning on learning C++? I'm not sure. I have just been sticking with Python for right now. My main goal was to develop kind of a mastery within one language before expanding out. I kind of have this theory that people oftentimes really collect languages kind of like Pokemon before they are ready to move on without actually an in-depth knowledge. Now, yeah, the languages all convey mainly the same things for the most part, but the syntax is different as people say. Uh, um, but do you actually know like the ins and outs of the language itself? And I kind of wanted to have that be one of my skills is that I was really knowledgeable about Python in its entirety rather than just kind of surface level across, five or six or whatever. That one is way more dense than the one I said. Which one are you talking about, Nunya? Are you talking about the automate the boring stuff? Which one is more dense? Are you talking about the Python crash or the data structures and algorithms? Or are you talking about the Python crash course? Ooh, whoa, don't roll over. AJ Brady, I think learning more about computer architecture and whatnot would be a nice next step. Yo, AJ Brady, you've really suggested a lot of great recommendations. You mind shooting me a message, either on YouTube or on Discord or something, with like those recommendations? I would really appreciate to have those in one place so I could go back and reference. Like I said, is I'm kind of running to a point where, like, yeah, it was kind of easy to figure out things to learn at the start because everything was new. But as I've kind of gained somewhat of a basic, or intermediate fluency in Python, I'm struggling to kind of know where to go next, right? Without more of a formal path to follow, like in school or whatnot. So If you guys have any suggestions about where to go next, I please suggest, because I'm currently considering, going down some more math topics, getting into calculus 1. I already took calculus 1 by doing a calculus 1 review, and then getting into linear algebra and discrete math and things along those lines. But also I want to, keep to programming as well, and learning about computer science as well. So what do you ever guys think? Please let me know. Yeah, it'll be easier in the long run to hook it up with a database. SQLite uses a file as a data store rather than having to have a server running. Yeah, so that's the one that we used in the CS50X course, was SQLite, and we used the .db files. So um, could I use that basically to create a database file off of my JSON information, my business information here? Yeah, you should do math, no way around it. Yeah, that's exactly what I'm thinking. I have this other theory. I'm very philosophical in my theories, but I have this other theory that people often shy away from the math. And if we can really develop a good understanding of the math and be able to apply it into some projects, into our code, that could really go a long way, because the math might make us stick out like a sore thumb when, coming to other people, competition in terms of like jobs or whatnot, because a lot of people, like, they do shy away from. I mean, on Reddit, the only thing you hear about with people that are worried about programming is how math heavy is it, and oh, I'm scared of the math. I don't want to go do a CS degree because I'm scared of the math, the math, the math. That's all you hear people complaining about, at least preliminarily, before they actually get into it. Nunez says yes. Also, everything is based on linear algebra, so you could take it first or do Calc 2. You can do the queries with simple Python. Yeah, they were mentioning that we can write it in Python, like the queries with Python. So we'll just have to read the docs and figure that out one day. We got a lot of work to do, but it's hard when I only have like an hour or two after work, and I get pretty tired. Using SQL Alchemy, I think, is the Python. What does ORM mean? Scary sticks. If you guys enjoy the stream and follow me, or enjoy the stream and what I'm doing here, please consider throwing a thumbs up. Today was a little bit later than normal. I do apologize. I had a project I had to get out at work. I go live every single day at 7 p.m. But today, like I said, it's just a one-off. Or every once in a while, I have to stay late for a project as a chemist, and so I was having to make the company money today. So thank you guys so much for bearing with me. But I'm probably gonna sign off here. It's almost midnight for me, and I got work tomorrow, and I didn't sleep much last night either. AJ says, so far I haven't had to apply any linear algebra or discrete math. It depends on what field you like to go into. Object relational model, object relational mapping. Object relational mapping. Okay. Yeah, I'm honestly really interested in like the data sides of things. I'm not really that interested in like the front end, the you know networks in terms of like connecting to like the internet and stuff like that. I'm not really interested in all that. I'm more like, from my science background and chemistry background, I'm more interested in like the data analysis, and the math really intrigues me. I personally, the reason I got into programming was um, because I have to compute these, basically kind of almost like a neural network by hand, just a very smaller one. It had very similar properties to where I had to balance basically these nodes or these inputs to basically output a desired key for a predictive model, a concentration model for my chemistry build. So I have to basically, balance, interpret, if I were to blend all these various serums together in various numbers of combinations, what would my output be? And I need it to get into these solidified ranges. So it takes me hours to have to compute this by hand, and I'm only able to compute, up to like five or so, imperfect to okay, decent, keys that would work for this model. But if I had a computer that was able to generate 100 different possible keys that were all optimized, then I could easily pick from it and reduce error within like the quality check departments, and it'd be a huge improvement to just the business in general. So that's why I got into programming. That sparked it in general. I haven't actually solved that issue because I don't think we have the tools to do that yet, but maybe one day we could get into that. But yeah, I'm gonna go ahead and sign off for here tonight, guys. Thank you so much for joining me. I'll be back tomorrow, 7 p.m. PST, like normal. Please give me suggestions for things that we can learn. We're going to be diving into Harvard CS50X Week 8 tomorrow, I believe, watching the first half of the lecture. We're almost done with that course, so once we finish that course, we're going to dive into some other courses. So whatever you guys suggest, whether it be math, computer architecture, operating systems, please let me know. And so 'cause I'm really, really, open to any sort of ideas because I don't really know where to go from here. I don't have any formal study guide or plan. I'm really kind of just winging it, whatever sounds interesting. And yeah, so thank you guys so much for joining me here. You guys are awesome. Thank you. I'll see you guys tomorrow. Peace out, guys. Yeah, AJ Brady, send me whatever you got on the Discord. Scikit-learn and TensorFlow would be good to dive into. Yeah, there's so many. That's what I'm talking about. Is there seems like there's there's always like a package or a module or a topic or a subject or something to learn, and it just seems never ending. Oh my goodness, that's so daunting. But all right, see you guys later. I'll see you tomorrow. Talk to me in the Discord. Peace out, guys.